Hey guys, it's ITW, and today we are going to be continuing our series on how exactly the computer works. And today, well, we are going to be talking about the CPU, which is by far the most complex part. Don't worry though, once you learn the CPU, everything else really just falls in line, so yeah. So the CPU is the main part of the computer. It's the part that actually manipulates data, if you remember the definition from last time. A computer is a device that manipulates, stores, and shows data. And it also actually manages all of the data that there is inside of the computer. It manages where it goes, and it can also, yeah. Anyways, also it's the part of the computer we might as well mention that actually follows instructions. If you've ever heard the famous saying, computers are useless, they can only give you answers, by, what's his name, Pablo Picasso. This is the part of the computer that actually gives you answers, and no other part of the other parts of the computer technically do, but this is the part that actually does the problem solving. So, yeah. And the CPU is so complex that it additionally has multiple parts just like a computer. And there's two main parts that one of them has subcategories and the other one sort of does. One of them is the control unit. It's basically the CNC of the computer and the CPU. And basically it's the really complicated part of the CPU. And we'll be getting into that much later, but yeah. It's the part of the CPU that's really going to give you nightmares. And the other part is the processing unit, which seems complex at first, but it's really the simpler part of it to actually implement. And so, what exactly are these things? We're going to be using an analogy where we're going to be comparing everything to a, what's it called? A workshop, and the processing unit, however, actually has two components. Now that may imply that it's more complicated, but it's really just the two components, and both of them are really simple. They're the registers and the arithmetic logic unit, or as it's more commonly referred to, the ALU. The registers are basically memory for the CPU, so it's basically like what you're working on at a given time. Like, you might be working on something else, but the stuff that you're working on at the moment is going to be stored in the ALU. Sorry, the registers. And then the ALU is just a calculator that does all the math, so it would be the part of the computer that actually adds 1 plus 1. It's the part of the computer that actually does subtracting, bit shifting, etc., etc., etc. We're actually going to be using the ALU that I showed off in my first video ever, and yeah, so how exactly can I think about these? Well, once again, we're going to be using the workshop analogy. So the ALU is basically the center of a workbench. It's where you use all sorts of tools to sort of manipulate your data, and it's the part that really thoroughly does the manipulation, yeah, anyways, each ALU has specific instructions or tools, for instance like bit shifting and addition and subtraction, that it specifically can use. And so basically every single CPU is different. Two of them might have similar ones, but ultimately the instruction set, which we're going to be getting to later, actually defines just how powerful each individual computer is. So yeah, and ALUs typically consist of at least an adder, because an adder is probably the most complicated, what's it called? It's probably the most complicated circuit that you're going to want in there. It's basically a collection of circuits also that do these sort of things. You just have your operands coming in, and then it just sends them out. It's just a pure calculator. And modern CPUs actually sometimes have actual multipliers and dividers, but that's just completely impractical for making a redstone computer. So, yeah. Anyways, so now let's discuss the registers. The registers are probably the simplest part of the computer. They're a really fast memory that you basically save the stuff that the ALU is editing. And the registers are basically a place that you can put stuff that you're not working out right now, but you will soon. And you might put them on the side of your workbench so you can really easily access them if you want to like hammer a new nail into them at some point. And the area that you can put your registers in is limited, and so you should only use it for short-term use. Now, let's say that you're building a four-legged chair, and you want to repeat each step that you're doing on every single one of the individual legs. What you would do in this analogy is you would take each one of the legs that you're not working on, and you would put it in a register, and then you would do each step to each one individually. And yeah, so then in the computer that we're going to be doing, we're going to have 4 registers, but modern computers can have hundreds of registers. And yeah, it's also the highest level of memory in the memory hierarchy, but that's way ahead of where we are now, and it doesn't really apply to Redstone. Anyways, now we get to enjoy the complexity of the control unit, because the control unit is the thing that controls everything in the computer and the CPU. And to be honest, in the workshop analogy, the best analogy for the control unit is you. Because you're the person that actually is going to take the hammer and is going to hammer in the nail into the chair. You're the person that's going to move the chair leg from the workbench to the side of the workbench to move on the next one. And yeah, it's basically the thing that, it's the thing that all the timing in a CPU happens in. And with Redstone specifically, just because of how different it is from real computers, it's just, you just actually have a massive amount of timing in this thing. And the timing, synchronizing a control unit is by far the hardest thing about making a computer in Minecraft. And so it's completely understandable if sometimes you might even give up when you just reach this point. So yeah, and it also contains extra bits of the computer that we might as well mention. Like if you've ever heard of a computer clock, you've probably never heard of a program counter, but those are 2 major components in the control unit. Actually, in the computer that we're going to be building, though, the program counter is actually one of the registers. It's not actually its own thing. So yeah, that actually makes some functions simpler, but it also means that you have less general register space. And considering we only have 3 registers after we take that one out, it's just a bit more difficult to program. Yeah. So how exactly are all of these parts connected in the CPU? Because each one of these things individually on its own is relatively useless. So if you didn't have data that flowed around the CPU, then each part really is useless. And the control unit's job is basically to regulate that. So other than that, it's basically down to the processing unit to basically have the ALU and the registers interact, and they're interacting in something called a data loop. And the data loop is the central place for the data flows from part to part in the computer. And it's a loop between the ALU and the registers. So basically you have your data coming out of the registers, goes through the ALU, and then it goes back to your registers. So it's in a loop. And every time that you go through a cycle like this, it's called a clock cycle. And it's basically the simplest form of a clock. Well, it's the fastest clock speed that you can get if you're only using the data loop, and that's all that you're really doing. Other stuff other cycles that you can do throughout the computer are almost always more complicated than this, and this is the thing that, in general, you're going to optimize it for, because it's the thing that's going to be able to add and subtract and other stuff. You don't really need your branching or getting memory to be quite as fast as this. And yeah, and so there's a few other relationships in the CPU, but they're not really that huge compared to the data loop. The registers can interact with the control unit through modes, but that's a topic for another time. And the ALU can interact with the control unit through flags for branching, but branching is way out there. So yeah. Now let's talk about the instruction set, which is actually the topic for tomorrow's video. That's where we're actually going to be discussing the instruction set for the computer that we're going to be building, though. So, yeah, an instruction set basically is a set of information that tells you what exactly what the computer is, and each computer's instruction set is unique, and that's basically the thing that defines your ALU, all the functions that it has. That's all defined in the instruction set. And basically, yeah, it's really different for all computers, and it's basically the first thing that you want to do. And two computers with an identical instruction set, yeah, you could one program from one of them, at least in machine code, would work on both of them if they had exactly identical instruction sets. One last thing that you might as well know is that one of the parts of the instruction set is also the bit layout, and the bit layout is basically it's basically how you define an individual instruction. So, like, if I was to send in a string of 8 ones and zeros, a string of 8 binary digits, then each one of them, the order that they were, basically the number that it could represent, the way that that defines the function that the CPU does is defined by the bit layout. So, yeah, but once again, this is all topics that we're going to do for next time, so thank you guys for watching, and I'll see you guys then.